So here is our game in action. When you can first select a player, each player is supposed to choose a different button for the player, and then you'll be given this screen. Here's the prompt here of what you're trying to do with the cards, and then you try to combine cards with operations in order to get closest to the number 43, which is the prompt. And then you can see as you press the cards, they go away and the value appears in the center of the screen. And then you can press submit button. Nothing will happen when you press submit at first, but what it does is it traps you in a loop until all the other players have pressed their submit button. And once the other players have pressed the submit button, your result will appear in the top corner, and it'll tell you you win, you lose, in the top left corner based on the other people's scores. And it'll also paste the other players' values into a little table that you can see in the top.
Hey guys, Jackson here to explain the GUI. So right here is the GUI of our main menu. You can see the title Smooth Operations, and we have a rules button and 3 player selection buttons, and a nice animation here. So if we look at the code view, we can see our startup function, which basically initializes all these variables we will be using later in the GUI. And here's the player 1 button pushed callback function. What it does is it runs our other GUI, which has our actual game in it, but it passes along this variable 1, which we will use later to determine which player it is. And we can see the same thing for player 2 button pushed and player 3 button pushed, but with 2 and 3. And then here is the rules button. If we press this, then it turns the rules off and turns them on. All right, moving on to our actual game GUI, you can see a ton of buttons and a ton of empty cards here. These will actually show up as cards when we run the game. But moving on to the code here, we have a startup function, which initializes a ton of variables. For example, the player answers initialize, the main deck initializes, and which player you are. It determines which player you are from the previous button you pushed on the other GUI. And it also gives you your cards that you will play with during the game. And also it plays the audio or song when you start it up. Now we have these buttons here. The when you press on your card, it will put it right here. It will put the value right here, as you can see in the demonstration video. And then you can use these operation buttons, which are used here. It basically inputs addition, subtraction, multiplication, or division into your answer string. And we use this later in the submit button, which is down here, to calculate the player's final answer based on which buttons have been pressed. Now, we also have a clear button. The code for that is right here. It will clear all the inputs the player has made in this GUI, and it will basically let you reset the answer you want to do. And then moving down to, again, to the submit button, you can see when the player submits their answer, it uploads their answer to our ThingSpeak channel. And then it will read the other 2 players' answers on ThingSpeak. And then it will calculate, it will retrieve those answers, and it will calculate the winner based on the prompt, basically who is closest to 43. And then it will display you win or you lose in this text box right here. And it will also display each player's answers in this table right here.
All right, Raymond here. I'm gonna go a little bit more in depth into the ThinkSpeak and prompt functions. So in our startup function, we wrote just to one field in ThinkSpeak because the way ThinkSpeak works, if you upload to one field, everything else is instantly NaN. And to bypass this, you have to upload to multiple fields at once. So we uploaded to one field that we're not using to pretty much reset all our data, so everything becomes NaN. And then when you submit, we read all the current answers and upload your answer to ThinkSpeak. And we keep doing this until everyone's answered. So pretty much when everything doesn't become NaN, that's when everyone's answered and we can progress from this while loop. So how the results are computed, we pretty much take the absolute value from the prompt to the person's answer, and we take the minimum and we create a Boolean matrix and then index that to determine the winner. And then all that is imported into the table.
Great, so I'm Michael and I'm here to explain some of the card mechanics and the deck mechanics. So here, as we first started the code, we were really struggling to figure out how to make a deck. We couldn't really find a way around just hard coding all the images and the numbers into the card names. And so what we have here is we just have a function that called adjust main deck that we use to basically initialize all the cards, the deck of 52 cards. We have each card name as a structure with the number value of the card and the image of the card, which we just use imread to read the PNG. And so this just works out really nicely with the rest of our code. We can either use the value of the card to compare people's answers, or we can use the image to display it. And then we have the draw function. The draw function is simple. It basically just, when you write the function, you pass the deck you're referring to, which is, in our case, the main deck, which we defined in adjust main deck, and the amount you want drawn. So it'll draw that many cards, or it'll draw that many cards. It'll give the player, most of the time, 7 cards that can be used by them, and it'll take the indexes of those cards and remove it from the original deck. And so whenever you draw cards, it removes those indexes from the deck. And so those are the main draw functions and card mechanics, and those are woven throughout the main GUI as we compare people's answers. And yeah.
All right, so here's our user-defined object-oriented programming class. It's basically creating a player. Player is the class, has some attributes, name, number, operations, and cards used. Here's the constructor, where we can make an instance of a player and give them a name and number. And then here's another function you can call through this class. You can pretty much assign them their cards and operations used.